In this video we're going to be introducing the concept of standard deviation. So standard deviation tells us how much the data is spread around the mean, or how much it deviates from the mean value. So first of all we'll look at why we need to use standard deviation. Let's say you're working for a removals company and you've been told that the mean weight of the boxes that you're going to lift is 20 kilograms. So it might be you go along and there are two boxes, one of them is 19 kilograms and the other one is 21 kilograms. So if we find the mean of that, we've got 19 plus 21 divided by 2 gives us our 20 kilograms. But it could also be the case that one of the boxes is just 1 kilogram and the other one could be up to 39 kilograms. So if we find the mean of these two, 1 plus 39 over 2 is still the same mean of 20 kilograms, but you can see there's a huge difference between the two different scenarios. So the standard deviation gives us a much better idea of the spread, or how far away each of the samples are away from the mean. So in this case it will be the weights of the different boxes and how far they are away from 20 kilograms. So here is the formula for standard deviation. Now yes, it does look very scary, but when you learn the right methods it's actually really easy to use, and the plus side is you don't need to remember it. It will be given to you on your formula sheet. So what we're going to do now, we're going to take it step by step and we're going to show you what all these symbols and letters stand for. So first, a quick introduction to the symbols you might not have seen before. This symbol here, we call it sigma, and all it means, it's the sum of. It just means the sum of. So it means you're adding together what's next to it. The next thing that you might not have seen before is this symbol here, which we call X bar, and that is just the mean, which you should be able to work out already. The only other things that we have are X itself, which refers to the value of the data, and N up here, which refers to the number of values. So this might all seem a lot to take in at once, so what we're going to do is we're going to split it up and show you how to work your way through a standard deviation question. For this example we've gone back to our storage boxes and we're going to say we've got 6 boxes with these weights in kilograms. Now because standard deviation is all about finding the spread from the mean, the deviation from the mean, well, the first thing we do is to find the mean, and remember we're calling the mean here X bar, and you find it in the normal way. So X bar is 6 add 7 add 9 add 9 add 10 add 13, all divided by 6, which gives us 9 kilograms, and we can see that 9 is roughly in the middle of this here, so we know we're on the right track. Now for step 2 you have to draw a table with 3 columns in it, and in your first column you're just going to put X, and X is just the values, so we have 6, 7, 9, 9, 10 and 13. So if we go and look at our equation, the first thing we're trying to do is we're trying to find the difference between each value and the mean. So that's what our next column is going to be. So at the top of the column we have x minus x bar, or x minus the mean, and we know the mean is 9, so we can say the first one, 6 minus 9 is minus 3, 7 minus 9 is minus 2, and so on. So you would have 9 minus 9 is 0, 0, 1, and 4. Standard deviation is really just the average of this difference between the x and the mean. But what happens if we try to add up the columns, the results in this column now? If we had minus 3 plus minus 2 plus 1 plus 4 would be the same as minus 5 plus 5, which would be 0. They would cancel out. So what we have to do, we have to find a way to get rid of these negative values, and that's what this next stage of the formula means. So what we're doing is we're going to square our x minus the means. I'll show you what I mean below. So our third and final column here, we're going to have x minus the mean squared. And all we're going to do is just square the values in the previous column. So we'll start off with minus 3 squared, which is 9, minus 2 squared is 4, 0 squared is 0, and again 1 squared is 1, and 4 squared is 16. So we now have 9, 4, 0, 0, 1 and 16 in our third column. Now for step 3, we're going to find the sum of our x minus the mean squared and divide it by n minus 1. And we can see here on the formula we have our sum, and it's all over n minus 1. Now this is just the same as finding the mean of this third column, except you have to remember you divide by n minus 1. And there's an important reason for this, and it's to do with the fact that you're taking a sample of the data and not the whole set of data. We won't go into that now because it's a little bit beyond this video, but I'll link to some information which will tell you a bit more about that. So on with step 3. What we're going to do is our sum of x minus mean squared all divided by n minus 1. Okay, and so that means the sum of 9 plus 4 plus 0 plus 0 plus 1 plus 16 and divided by 6 minus 1. So we're going to end up with 30 divided by 5, which gives us a final answer of 6. Now I know I said this was the final answer, but there is one last step. When we were finding the differences, we squared the data. So our final step, we have to undo this and we have to find the square root of our answer. And if we go right back to our original equation, we've got to find this square root of everything. So it's just a case of, with your calculator, you find the square root of 6, which is 2.4522 decimal places. So we can say that the standard deviation from the mean of our set of data is 2.45 kilograms. Now this probably seems like quite a long process to start with first time you do it, But with a little bit of practice, it's really not that simple. Just remember, find the mean, draw your table, and find the value of x minus the mean squared. Then just find the sum, divide it by n minus 1, and finally you've got to remember to square root it. So now we're going to try some worked examples yourselves. For this first example, we're going to use these weights for the boxes, and we'll go through this step by step. So first of all, I want you to find the mean. So to find the mean, as usual, you'll find the sum of all the values and divide by n, the number. We can actually write this in this format with sigma. We can say the sum of all the x's over n is the same as the mean, and it's just the same as you would do normally. 4 plus 5 plus 7 plus 5 plus 6 plus 3 divided by 6 is 30 divided by 6, which is 5, so we have a mean of 5. For your next step, I want you to draw your table. So remember that the values that go on the table are x minus the mean, and x minus the mean squared. Here are your values of x. Here's x minus the mean, and here's x minus the mean squared. So now I want you to find the sum of x minus the mean squared and divide by n minus 1. This comes to 10 divided by 5, which is 2. So finally, I want you to find the square root to 2 decimal places. So the square root of 2 is 1.41 to 2 decimal places. So that gives us a standard deviation of 1.41 kilograms. Now for our final worked example, I want to see if you can work this one through all the way before you find the answer. So the mean for this one is 5, and if you filled your table in correctly, you should have found that the sum is 30. So the sum of x minus the mean squared n minus 1 is 30 divided by 4, and that gives you 7.5. And so finally you can find your square root of 7.5, and you should get the answer of 2.74 to 2 decimal places.